let's get right into the topic. So you went through the Django tutorials, you maybe went through the post tutorial, and you created your awesome new Django web app. Maybe it's something like a database for family culinary recipes or something similar, something you want to share now with some more people. And then you come into this first challenge of basically how do you share with other people if it's just running locally on your machine. So how do you let others use it? So you just need to deploy it. Sounds simple. Well, if you start researching what are the options out there for simply deploying a Django app, you'll very quickly jump into this documentation page on the Django docs, which starts into some very interesting subtopics like what is Apache and what's uwsgi and how do you connect these two. Basically, this brings us into the first chapter of deploying Django, which is self-hosting. So, to take a step back, some of the things we're going to talk in this first segment of the presentation is connecting the core components. So to deploy Django web app, you need a web server that's going to be hosting your app. You need a domain that's going to be pointing users to this web server. If you're doing anything more complex using Django models, you're going to have to store them in some sort of database or multiple databases. And then you have some core actions, like you want to start everything up and keep it running, so to allow people to connect to the server. And lots of the things, maybe not the least though, is the security aspect. So you want to keep track of your error logs, warnings, and make sure everything is basically transferred in an encrypted manner to the client. That you have backups and so on. Okay, good. So are you ready to jump into the rabbit hole? Let's now dive into each of these components and see how you would set them up if you were to self-host a Django web app. So the web server first. So no, we're not going to use Apache like the official docs still predicts in the first place. So these days we'd go for something like nginx. That's another web server you can use. It's much more popular and better supported. Now a problem with nginx, Apache for that matter as well, is that it doesn't support Django directly. So you basically need to tell it how to run Django. So it doesn't know how to run your manage by run server script. And you wouldn't run Python managed by run server directly either, because it's not performant. It's meant for debugging purposes, and not safe to run into production. So what you would need to do is set up a production-ready application server like uwsgi or gunicorn that knows how to run your Django app, and then you would route this part of the traffic from the nginx web server to something like uwsgi or gunicorn. But then we come to static files and media files, which they don't go to this Python server. They are served by the web server itself because that's more efficient. Okay, so you figure out how to set this up, then you are connecting to the domain. Now you need to register a domain. You need a domain register. Namecheap is a good option. So if you have a fixed IP of your server, you would set up an A record, or if you're forwarding to another domain, you would set up a CNAME record. Just don't forget, if you also use the domain for MX rules for emails, basically you have to make sure they play nicely. So check if your register has a name or alias support. You can also, which is a very common approach, just connect your app via a subdomain like app.mydomain.com. Good. Okay, so we've connected the domain to the web server. Next comes the database. So you want Postgres for the relational part, for storing your persistent Django models. You might need additional databases. For example, if you have a task queue in Celery, you need a backend for that. You could use Redis, which is a decent option. And now you need to go through each of these services, follow their tutorials, and get them set up. So now let's say you've set everything up. So how do you start it? Some things like nginx and Postgres, your operating system is going to start up automatically as soon as it's up. So let's say you use an Ubuntu VM, it will just start up these services. But what about your Python server? So say you use uwsgi. For these things, you need to set up your own service to start them up. And for this, you could use either systemd, which comes with Debian-based operating systems, or you could install a separate service like supervisor. Yeah, it's another one of these like very long and detailed tutorial websites that you need to go through, learn the ins and outs of to get it configured. After you have the services up and running, you still need to set up logging and monitoring because, of course, things are going to get broken. You're going to get errors occasionally, and you're going to want to know about them. So get some notifications about these errors. And lastly, I mentioned security. Oh yeah, we need to encrypt the traffic. Otherwise, the new Chrome browser is going to pop up these ugly, not secure warnings for your users. So you need to use Let's Encrypt, another tutorial. But then again, Let's Encrypt expired. So you need to set up a cron rule that's going to auto-update your certificate. You're going to have to upgrade your nginx config, and so on. Are you tired yet? Well, there are still upgrades to worry about. So hope you're upgrading your operating system because it doesn't do it on its own. So say you used an Ubuntu virtual machine to host the web server. Well, it gets notifications about security upgrades, but it doesn't run on its own. So you need to enable unattended upgrades if you want to have these most important security updates. You still need to occasionally, log in and check up on things to just make sure you didn't miss another, important update that doesn't come in automatically. I've created this handy little Ansible script that enables unattended upgrades for your server. That's not on by default for some reason. And, don't even get me started on backups. So you have all of these services now that, now you want to back up in case the computer crashes, because as you know, there are only two types of hard drives that are dying. So when they do die, you want to have a backup you can bring up on another machine. Okay, we have systemd, uwsgi, Sentry, nginx, Namecheap, Let's Encrypt. It's really a whirlwind out there of all these technologies you need to put together to get your web server running. And you can see, what are some of the downsides of this self-hosted approach. I was a bit fast in this segment, so I hope you're still bearing with me. So in summary, I wanted to say that we really need to set up a bunch of these services, and we are the ones responsible for maintaining them once we do that. These services will break and change over time, which is a problem. And, we still didn't cover how do we tell Django where everything is, how to configure everything. Can this be automated? Yes, to an extent. So, there are many things you can do with things like Ansible or other configuration management tools, Salt, Chef, Puppet. But there are better ways, which leads us to chapter 2, the 12-factor app, which is the part I actually want to focus on much more than the self-hosted approach. So the approach we're taking here is you have a problem. Well, great, start throwing money at it. This is where the platform as a service model comes in. There are lots of services out there function in this way. One of the popular hosting services is Heroku, and at around $7 a month, you can get a Heroku dyno. And what is dyno? Well, it's something that knows how to run your Django app. How does it work under the hood? Who knows? It's someone else's problem. That's what we're paying them for. It's a very simple approach. It's a bit sounds crude maybe, but you'll get to appreciate this hopefully, especially after the whole self-hosted segment. So remember all those services that we had to painstakingly set up on our own and maintain later on. Well, in Heroku, they just come built in. So if you need something like Postgres or Redis, you can install it as a plugin, and it's just connected to your app. There's even a whole marketplace of these services you can use. If you notice later on, when you need Elasticsearch, maybe for a full text search, as I needed to add in one of my recent projects, you can just dig through this app store and find the service you need and enable it. Is there a catch? There always is one. So besides from paying more money for it, there is some amount of configuration necessary to make this plugin model work. Now, the way Heroku handles this is they came up with the full-factor app methodology, which I'm going to explain. It requires us to rewire our app in a way, but don't worry, it's actually a good thing to think in such a way, as you'll see. So let's quickly glance at these 12 factors. I'm not going to focus at all of them because some of them are going to take us on weird segues. The important ones are that you have a single code base, which is trapped in a revision control, and it allows you to do many deploys from it. So you have one Git repo that is responsible for maybe your staging, production, dev server, and so on. And number 3, the configuration is stored in the environment, or more precisely, in environment variables. That's something to really think about and internalize. So we don't have any config files or text files. The code is always the same, and in the server's environment variables, we set everything that's necessary to actually describe our deployment. There are other things involved in here, and they're all kind of good practices, and it's good to read more about this. But we want to get to the more practical aspects, so let's move on. So how do we start? Well, you can of course follow the official Heroku tutorial on getting started with hosting a Django app there. What I'm going to explain in this talk is how you can do it using this Django-rest YAML generator that I've created, and is open source. It's written in JavaScript, but don't tell anyone. There are reasons why I did it in such a way. And it's fairly easy to get started. So assuming you have a couple of basic dependencies installed, like Python, Node, you can install Yeoman, which is the framework I'm using for my generator. You can then install the specific generator called generator-django-rest, and then you can get started. So now I'm going to switch from my slides to the terminal because I have a demo to show. Can you see my terminal? Okay.
Sorry, I was muted. Yeah, it looks good.
Okay, great. So I'm making a new folder for starters. I'm going to call my app Aviato. And inside it, I do yo Django rest. And that's everything you need once you've installed the npm packages to get the app started. So you follow this interactive prompt to answer a few questions, like I'm going to keep the name of the app as Aviato. There is some more front-end support that I'm not going to get into now. You can give it a GitHub URL if you want to sync with GitHub right away. And there it is. It's created this project layout for us. And we're going to examine later on in an editor what we have in there. I'm going to have to magnify the screen a couple of times so you see everything. Basically, there is a scripts folder in there where you have a couple of useful scripts. One is install, which I'm going to call first now before I start explaining anything inside the project. And what the install script does is it installs all of the dependencies locally on your machine, and it's using pipenv as the package manager on top of pip itself. So the repository is a standard Django project you would get if you just did a Django start project. It comes with some documentation inside this hacking MD folder showing you how to get started and how to later on deploy the app. Most of the magic is contained inside this scripts folder. So there's an install script that basically initializes the Git repo, installs the file, installs the dependencies, and creates an empty Postgres database. And we have a start script that will then run everything using Honcho. Honcho is Python's program for basically parsing these proc files, where you can specify in every line what service are you starting. Okay, let's see what's happening in terminal. It's running some Python dependencies. If we look at the app itself, it's fairly boring. So the only thing that's really different than the normal Django project is the settings file, settings.py. And what I added inside the generator is the Django environment project, which allows you to then, in a more streamlined way, extract values from environment variables. So as I said, in the 12-factor app paradigm, all of the information about your deployment comes from these environment variables. So you can do things like, I don't know, extract the secret key from the secret key environment variable. If there is, let's see, if there is a Redis URL inside the environment, you would pull it out like this by querying the env object, and so on. So by now, okay, all the dependencies have been installed. So I can now go into the scripts folder and call the start script. And what this does now is it starts all of the processes from the proc file, so the Celery worker, the web process, and it should be running now on localhost 8000. And you can see now the template, it's running live. So it's a Django-rest framework project. So you have the REST dashboard here, and you have the normal Django admin interface that you've hopefully learned about in the tutorial you were following before you even started on the task of deploying the Django web app. Great. Now, just starting an app locally probably isn't so impressive by itself. So this takes us to the next part of what we can do with our generator-django-rest project, which is deploying the app. So if we open the hacking MD file, here we have some instructions of how to create a Heroku app where we can deploy this Git repo. So I'm going to create it right now. I'm just call it my Aviato because Aviato is taken. This first command basically creates the app on Heroku. The second one just creates a local Git remote, so that when I do a git push Heroku master, my repo knows where it's pushing to. And then I'm creating some plugins on Heroku. This is the part I mentioned where Heroku treats everything as a plugin, all of these external services. So if I open my dashboard, I should see the new app I've just created here in my personal Heroku apps. And here is Aviato. I can see it's created. I've attached a Heroku Postgres plugin. In a similar manner, I can create a new add-on for the Redis database for the Celery backend. and all of these things, they're visible in the dashboard of your app. So if we just give it a second, it should instantiate the Redis add-on as well. We can see it's working here. And once all of this is configured, I'll be able to do scripts deploy, which then does the magic sauce of, I can show you basically what it does. Git push Heroku master. So some of these scripts are really very simple. We'll just wait for this to provision. It's done, great. So I can do scripts deploy sh. And it's gonna take a while, but basically that's everything you need to do. In just a few minutes, you deployed your whole app without doing all of these steps that I mentioned in the first part of installing all the servers to get your app running on Heroku. I'm gonna continue with my slides now. We'll verify that this is working later. So once everything is live, you should see the same interface I showed locally just on the internet on myaviato.herokuapp.com. So how does it work? I've shown you basically the settings part. That's the most important thing. So basically by saying specifying inside the project where your Redis and Postgres and so on databases are coming from, Heroku knows how to connect these add-ons, the Heroku add-on, the Postgres add-on and the Redis add-on to your Django app, and they just work. So because they use all of these standard port numbers, URLs, and so on, your Django app will just know how to connect to these services. And the best part is all of these services are managed by Heroku's DevOps engineers, so they keep everything running. Let me just pop right into the terminal to double check if this is done. Okay, it's released. I can now open this URL, and the app should be live on the internet. Awesome. So you can share this with your family. They can use your culinary recipe app, and everything should be there as you'd expect it to. Perfect. That brings us to the end of chapter 2. And now we're in part 3 or chapter 3, which is the self-hosted 12-factor app. Okay, so why do we get into this? So Heroku, for all its benefits, can get a little expensive. So these $7 a month dynos can easily become $14 a month dynos if you need periodic tasks. So maybe you need a scheduler that has to be a separate process, so you need to cash out for another dyno. Also, this might just be, like we mentioned, a hobby project, maybe a culinary app for your family. Maybe it's a startup project that's not generating any revenue yet. Maybe you don't really have many users just yet. So if you're not making any money from these apps, these costs can really add up quickly. Luckily, the open source world, as with a lot of things, has our back. So in comes Doku. Doku is an open source alternative to Heroku. So it's a self-hosted Heroku. Now, it maybe sounds a bit counterintuitive. So like we talked about all the downsides of self-hosting in the first part. Now we want to self-host something. Well, it's kind of a nice compromise. So it's a bit cheaper. So if you get a $5 DigitalOcean droplet, or in the EU, there's K-Away, which I use, you can get this kind of your own Heroku running, where you can run lots more apps. So it doesn't have to be just a single application. It can be tens of apps easily running on a single server of yours, especially if these are all hobby projects where you don't have that much traffic. But it respects the Heroku 12-factor app methodology. So as long as your app is running on Heroku, you can deploy it to Doku as well. And this is the approach of treating your service as cattle, not as cats, not as pets. So if something is not working, just commission a new VM, set up a new Docker instance. It's just a couple of commands to get it running, and you can just deploy there from scratch. You don't have to fix things that aren't working and worry too much about the configurations and so on. So how do you do it? So if you follow the template that I've shared in the hacking MD file, you can find the instructions. This is basically the whole procedure. You again install a couple of plugins, create the app on your Docker instance, and link up the databases. A few commands to get Let's Encrypt working to have HTTPS, and that's it. So I'm not going to follow these steps to save time, but basically by following the same procedure, you can get your app running on your own server. Okay, this is basically it's what I wanted to mention from ways of deploying Django. I have a little aside though to talk about what about production. So, these techniques I've talked about, they mostly are good for your own projects and when you're first starting out, even if it's a startup project. But when you get to the level where you have lots of users, very serious use, you're talking about uptime, scalability to new numbers of users. It's a whole different topic, and I really would encourage checking out some old PyCons. There are lots of good talks to learn about these things. Some pointers that I'd mention is that there are ways to deploy the app using Amazon's container service. You can use their database services. Kubernetes is a big thing. There are also ways to deploy your Django app using AWS Lambda in a serverless manner, which is a different architecture. But the reason why I didn't want to talk about these approaches is that they're, in my opinion, not the best approaches when you're just first starting out. So in this stage, you probably want to see if users are going to like your app at all or not. Maybe it doesn't make that much sense to put all this effort into making a super scalable app when you still don't know how useful it's going to be to people. So maybe don't dive into this rabbit hole, and it really is a rabbit hole. And when you do, either educate yourself to become a good DevOps engineer or hire a good DevOps engineer, because this really is a topic all onto itself. So to conclude, don't reinvent the wheel. The 12-factor app methodology rocks, and Heroku and Docker rock. They're really useful and good projects to check out. And most importantly, get out and have fun working on your side projects. Thank you.
Awesome. Thanks so much, Dražen. This was great. Can we get Dražen a round of applause in the chat? If you do have questions in the chat, please ask them down below or ask them to the right over there. I do actually have a question. So one of the things that I had a side project going, it was the Slack bot for Chicago Python. And the thing that I always found is how am I supposed to back up my database? Do you have any recommendations on that?
Yeah, I do. So basically with Heroku, it's fairly easy. You can set up snapshots in there. There is even a separate Heroku Postgres backup add-on that really focuses just on backups. So you can set up a schedule to do nightly backups, weekly backups, and so on. And it's very easy, from just the web interface without getting too technical to bring back data from previous timestamp.
Yeah. So that's just gonna be an add-on, a couple dollars more or something like that a month?
Exactly. Yeah. I think it even starts free. But yeah, as with all of these Heroku things, as soon as you exceed the free tiers, like the Postgres add-on, I think it has something like 10,000 database rows, which you exceed this fairly quickly. That's why I also wanted to give an option of how to do something without Heroku. If you're a bit constrained on your budget.
Yeah, and definitely like if your app becomes serious, like your database is the number one thing you should start thinking about. You probably should just like start paying somebody to do that for you versus like worrying about it yourself. So we do
Exactly.
have a question in the chat. They're wondering, can the Yeoman generator be used for creating an app that can expect heavy traffic?
So, like I said, there's the getting your app deployed part, and there's the real production. And I think these are two separate topics. Like, sure, you can build on the app generated with my Yeoman generator. You can start with that, and start building this very scalable architecture from it. It definitely doesn't include all of the things you would have to get into, all of the load balancing and configuring some sort of auto layover to different instances if one is not available. So that's definitely something that's a separate topic, and we get into parts that are more app specific in these cases, I think, because different app architectures have different needs, and especially it really depends how you want to run your app to make it more scalable. So one way would be just to start with, if you are deploying it on Heroku. Heroku allows you to just add more processes, more instances, so it's not that difficult to add scalability in such a way. If you opt for something like Docker containers on Doku, there it gets a bit more tricky. And I'm not really an expert on each particular of these workflows, so I intentionally didn't want to make this a part of the project. If there are some people who have ideas of how to already build this, and I'm open to suggestions. I just I wouldn't start from the get-go when you're just starting a project with this super scalability in mind. You don't have to be Google from day one.
Yeah, it's they always say it's like, what is it? Make it, then you make it work, and then finally you make it fast. Like, don't solve problems that you don't have. Like, your data model can probably do most of the heavy lifting if you like step back and think about it. So just going down that sort of same avenue, like when do you start thinking about scaling out from, say, like just like your web app to a web app with a worker process?
Well, that for me comes pretty naturally. So as soon as I have some tasks that would be choking up the responses to web requests too much. For example, email sending is a perfect example. So you need to talk to a third-party API. An email is anyway something that doesn't arrive instantaneously, so it's usually a natural candidate to be separated into a worker process, and there you usually bring in Celery. Again, it depends on your app specifics. So some domains have different needs. Some domains might not even need an async task queue like Celery. But I find in most examples, you fairly soon need something like email sending, and there you plug in the Celery worker just to be able to do that.
Yeah, for sure. It's always I think email, it's like I'm always using like requests to do something. So it's like I don't want my request to hang for a minute while I'm using another library to go out and make more requests.
Exactly. Yeah.
So before we do let you go, do you have any action items or words of wisdom for our community?
Yeah, well, I say once again, I really encourage all of you to, start working on your side projects. I that's one of the things I really appreciate about the Python community, and that I like to see more of. One maybe call to action would be, just go check out generator-django-rest. I'm gonna post the slides on this link. You can't see it anymore. Okay, yeah. So I'm gonna post the slides on these link on this link, and basically I'd really like you to try out the project and let me know what you think, even if you have some issues. For example, the Windows support right now is kind of non-existent. I focus mainly on Mac OS and Linux, so I'd really like to see more people try the project out. Let me know how it works for them, and maybe together we can make it more general purpose to make easing into Django easier for newcomers and just more experienced developers who just have never deployed Django before. So
Awesome.
That's it from me. Thank you.
Actually, we got one more question, but could you also mind sharing? We just had a question come in, but before we get to that, do you mind sharing a link to your slides in the YouTube comments as well, just so people have it there?
Yes, definitely. I'll do
awesome,
that.
Perfect. And we have one last question. And what is a good intermediate or advanced book about specifically Django programming?
So for a beginner resource, I usually recommend the Django Growth tutorial. I find it even sometimes better than the official tutorial. And as far as advanced resources, I would recommend the 2 Scoops of Django. I think that's a natural candidate. I think there's a new version coming out now, Django 3. Basically, it covers all of these more advanced recipes on how to deal with more real life examples, and gives you some good opinionated tips and tricks. I'll post these links in the chat now as soon as I hand over the microphone.
Awesome. Yeah, and that book actually just released in early release, I think a couple of weeks ago. So they are updating it, I've heard, for async Django, which is going to be interesting to do.
Awesome.
Yeah. Well, thanks so much. Thanks so much, Dražen. It was great having you on. You've actually been our guest from the furthest away.
Thank you, Ali. I'm glad you claimed this title.
Awesome.
Well, talk to you soon then.
Yeah, thanks. We'll hope to see you at PyCon next year.